Hello everyone, my name is Kundan Sharma. Today I am here to do numericals on gravitational force and momentum vector of chapter 3 for my physics 221 class. And the question is, we are given a system in which the earth revolves around the sun. We are given the mass of the earth, the position of the earth, and what we want to find is the force of gravitation on earth by the sun and the change in momentum of the earth after 6 days. So let's assume this to be sun and this to be earth. So it is revolving around the sun, and since we are given mass of the earth, mass of the sun, position of the earth, and since it says that there is a coordinate system whose origin is at the center of the sun, we can take the position of the sun to be 0, 0, 0, and change in time delta t is 6 days. So first let's convert 6 days into seconds. That would be 5 into 24 into 60 into 60. That would be 518,400 seconds. And now let's find the separation between earth and sun. So when we subtract the position of earth from the sun, we get the separation to be r2 minus r1 minus r2, that is 3 into 10 to the power 10 comma 0 comma 0 meter. And we know that the force of gravitation, let's assume that to be F, is G times mass of the earth times mass of the suns divided by square of distance between them times unit vector r cap. Before we find the force of gravitation, we need to get the magnitude of r and the value of r cap. So magnitude of r would be the square of each individual elements, and we put it on the square root. It would come out to be 3 into 10 to the power 10, and r cap would be vector r divided by magnitude of r, and we get that value to be 1 comma 0 comma 0. Now finally we can calculate the force of gravitation F, that is G m mass of earth mass of sun over r squared dot r cap. So substituting the value, we get the value of gravitational force to be 8.89 into 10 to the power 23 comma 0 comma 0 Newton. So we are done with the first part. Now let's look at the second part of the question. The second question tells us to find the change in momentum after 6 days. So first let's look at the initial momentum, and let's assume that to be P1. Momentum would be mass times velocity. Mass of the earth is 6 into 10 to the power 24, and the initial velocity was 0, 4 into 10 to the power 4, 0, which was already given. So we get the value of initial momentum to be 0, 2.4 into 10 to the power 29, 0 kg meter per second. And we already calculated the net force over here, which is 8.89 into 10 to the power 23, 0, 0. And we know that the net force F net would be equals to change in momentum over change in time. And what we want to find is the final momentum, that is the momentum after 6 days. So F net would be, let's assume P2 to be the final momentum. Change in momentum would be P2 minus P1. P1 is the initial momentum, and delta T, which is the change in time. So doing the simple algebra, we get P2 to be net force into change in time plus initial momentum. Net force we already calculated above. Change in time we already calculated this. We already converted 6 days into seconds. This is the value. And initial momentum we just calculated over here, and we just substitute P1 with this value. So after multiplying net force with change in time and adding the initial momentum, we get the final momentum P2 to be 4.61 into 10 to the power 29, 2.4 into 10 to the power 29, 0 kg meter per second. Therefore, the final momentum of the earth after 6 days is 4.61 into 10 to the power 29, 2.4 into 10 to the power 29, 0 kg meter per second. Thank you. I hope you like it.